Hey everybody, welcome to the second to last day of first session. All right, so it's Monday. It is crunch time for you guys. I've kind of been saying it all last week that you guys need to make sure you're caught up and you've got everything done. And then I would suggest going back through and looking to see, where um, your grade's at that point, and depending on what you want to accomplish, whether you're just trying to pass the course for credit, which means you just need a 60% or higher, then you need to make sure that your grade's at a 60% or higher, and you can see that on Aries. Or if you're looking for replacing a grade from last year, then you need to make sure that that grade is higher than what it was from last year. So, like it says, you are almost out of time. If you guys haven't already, make sure that you take a look at the points in Aries and make sure that that's correct. I've got 31 students that I have to go through, so it's possible that I could have made a mistake. So double check that as well. All right. Another big thing here is everything is going to be open today. Starting this morning at 8 a.m. Everything should be open that's left in the course. That means the mastery test. That means the unit test. That means your final. Okay, so the final exam is going to be open at 8 a.m. and it will close. Big thing right here. It will close at 11 a.m. on June 16th. Okay, so that's Tuesday. So there are no retakes. So you need to make sure that you are prepped and ready to go for that final. If for some reason you need to step away, then you need to click that save and exit, and I believe that should work so that you don't lose any of your work from what you've done so far. And yeah, big thing is 11 a.m. on Tuesday. Okay, you guys are going to need to be done. That means with everything. Okay, so you can't, contact me at noon and say, "Oh, I need one more thing," because we have to have our grades in. Teachers, we have to have our grades in after that, which is why this is closing at 11. All right. And then we need to go through and determine whether you're getting a grade or if you're getting just credit. So that's why we're going to need the rest of the time to do that. So Monday, cram day. All right. Let's see. Yeah. So if you guys have questions, please let me know. I want to kind of get into things, your notes for today. You guys have been talking about systems of equations. You guys have been looking at solving system of equations using substitution and using elimination. One of the ways you can solve them is also by graphing them, right? So you can solve systems by graphing them. It's not always the easiest, and it's can be tedious, but that is one way to do it. All right. Let's see something else. If let's see what happens so you guys can read through this. Once you guys solve it, you should check your solution, and the way you can check your solutions by putting those x and y values back into the equation and making sure that they work for both of your equations or your system of equations. All right. So what can happen? There is times. Let me see. I can just move that. All right. There we go. All right. One solution. What would one solution look like? That means that two lines are going to intersect each other at one point. And that means there is only one solution to it. Infinitely many solutions. So that means that the lines are the same. So if you put your equations into slope-intercept form, remember slope-intercept form is y equals mx plus b. If you put it in that form, then that means you guys can compare it right away and see, oh, are those equations the same? If they're the same, that means there are infinitely many solutions. Okay, and then the third one is no solutions. And the reason that there would be no solution is because that they are parallel. And you should know that lines are parallel, have the same slope, but a different y-intercept. All right, same slope, different y-intercept. Those are going to be parallel lines. I'm going to try to go through this, and this might make my notes a little bit long today, but I'm going to try to go through some examples here for you guys. All right, if I'm going to graph a line, So let's say for example 1 here, if I'm going to graph this, there's different ways to graph. So you guys choose the best method that you like to graph. I personally like to start with the y-intercept and then use the slope to find more points. So the y-intercept on this one is +1. I put a point there. The slope is -2, which means the slope is -2/1, which means that my rise over run is go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. All right, now this is a system of equations, so these are equal signs, so that means I'm going to draw a straight line. So that's my first one. Okay, my second one, all right, I'm going to start at -6. 1, 2, 3, 4, 5, 6, -6. And my slope is 1/3, which means I go up 1/3. 2, 3. Oh, perfect. That makes it easy. It's nice when it makes it easy for you to find a solution. Okay, now my solution point is where do these two lines intersect each other? And that is that point right there. Okay, and what is that coordinate point where these two lines intersect each other? Let's see. It looks like it's at 1, 2, 3, comma 1, 2, 3, 4, 5. -5 because we went down. 3, -5. That's my solution. Okay? And if I want to check my answer, then what I would do is I'd plug in 3 goes in for x, -5 goes in for y, and I make sure that they work on both equations. So it looks something like this. -5 equals -2 times 3 plus 1. -5 equals -6 plus 1. And -6 plus 1 equals -5. Does -5 equal -5? Yes. So that means that it worked. So let's try the other one. -5 equals 1/3 times 3 minus 6. And you're like, oh my God, there's a fraction. That's all right. No big deal. Guess what? 1/3 times 3. Well, 3 is the same thing as 3/1. Anytime you have the same number on top and on bottom, they cancel each other out. And so that leaves us with a 1 minus 6, right? Because really what you left is 1 times 1 over 1 times 1. So you have 1/1, which is 1. And that leaves me with -5 equals 1 minus 6 is -5. And that is a yes. All right. So that's how you guys can check your solutions. All right. Earlier, I told you guys the best way to go about these is by putting them the equations into slope-intercept form. So if they're not in slope-intercept form, that should be the first thing you do. So for like this one, what I do is I divide everything by 2. And so the equation would be y equals -3x minus 2. Okay, so there are my two equations. And if I'm going to graph that one, I start at -2. Then my slope is -3, but it's as a fraction, it's -3/1. So that means I go down 3, 2, 3, and to the right 1. Kind of running out of room there, so I'm going to go the opposite direction. I'm going to go up 3, 1, 2, 3, to the left 1. Up 3, 1, 2, 3, to the left 1. Okay, so you can do the opposite. Connect those points. All right, and then let's see what the other one's going to be. It's this one right here. Start at 6. It has a slope. Oh, there's nothing there, but guess what? It's called a shy guy. It's a 1. Even though you don't see it, there's a 1 there, and it's 1/1. So that means if I go up 1, I go to the right 1. Which also means if I go down 1, I go to the left 1. Down 1 to the left 1. Oh, perfect. I don't need to do any more. Connect those points. Okay, and then I found my solution. That's this point right here. And that point is at -2, 1, 2, 3, 4. -2, 4. Okay, and just like I did for example number 1, you're going to plug in -2 for your x value, and you're going to plug in 4 for your y value in both these equations, and you're going to solve them and make sure that the two sides equal each other. That means it's a solution. Okay. One more, number 3. All right. First one's equation's already in slope-intercept. Let's change the next one. Divide everything by 6. That's going to leave me with y equals negative 1 over 3x. Nope. What did I do here? Yep. I don't want to do that yet. Sorry. I'm going to back up a step. I don't want to divide everything by 6 because I want to get the y by itself first. So what I want to do first is I want to add 2x to both sides. Now I've got 6y equals 2x minus 6. You can't combine the 2x and the minus 6. They're not like terms. So that's why I didn't try to put them all together in one term. Then I'm going to divide both sides by 6. And now I've got y equals 1/3 x minus 1. Oh man, 1/3 x minus 1. Guess what that means? Take a look at the other equation. What do we have here? Oh, what's the slope of this equation? 1/3. What's the slope of this equation? 1/3. What's the y-intercept? -1 on this one. What's the y-intercept here? +2. Well, same slope, different y-intercept. Guess what that means? These lines are parallel lines. And parallel lines, if you guys remember from right over here, means that there are no solutions. Okay, there is a no solution here. Now I can graph the lines and the lines would never cross and never intersect each other, right? And that's what you get with parallel lines. Moving on. All right, so that's a little review from what you guys have already been kind of working on and you guys have already been kind of exposed to. Now, if we're going to take a look at systems of inequalities, now this one has to do with shading. So there's a lot of shading that goes on with this one. And you guys just need to make sure you're shading in the right spot. Is it above the line? Is it below the line? And you guys want to try not to make it too messy when you're shading. That way you guys can see where the lines are overlapping each other. And this is what I mean. All right, so what you're looking for is you're looking for an overlapping region. Okay, that is going to be the solution point. Where do these lines, the shading of these inequalities, where do they overlap? That's the solution. So in this case, there's not going to be necessarily one solution. There's going to be many solutions. It's any point in that overlapping region. Okay, so any coordinate point in there can be a possible solution. All right, so if I'm going to graph this, like before, I'm going to graph using my y-intercept as my first method.
Who are the connecting things?
I don't know, guys.
Well, you put it away. Find them, please.
I'll be right back, you guys.